Welcome to my video on 6-1B compound interest. So today we're going to be looking at a very specific type of exponential function that has to do with money. So for the do now, I have the question, if I have $500 in my account after 4 years investing at 2.5% compounded annually, how much money did I start with? Well, we have to pick out a few keywords in this word problem to see how it's related to what we have already done. So in case you are not sure, investing, right? To invest your money means that you are giving your money to the bank, putting it into an account, and in return, the bank is going to give you money back, extra money on top. Okay? So that extra money that they give you is called interest. And basically, the idea behind interest is the longer you have your money in this account, the more interest your money can make. Now, how much money are you making? Well, that is what this percentage is for. Okay, so you're going to be making 2.5% interest, and that interest is going to be compounded annually. The word compounded means, it basically tells us when they are applying the interest. So for this account, they are giving you interest every year because that's what annually means. Okay? So if I have an account in this bank, we should expect 2.5% increase in my money every single year. So that being said, although we didn't necessarily talk about this specifically, this kind of follows the equation that we looked at yesterday. That looks like this, right? Y is equal to A, which is an initial amount, right? Times 1 plus R, which is our growth rate with a percentage, right? The R is a percentage in decimals, and when we add it to the 1, we know we are increasing. Now, what is my time period on this question? Well, we're looking at years, right? You put the money in the account for 4 years. The money is being compounded annually 4 years. So the time unit on our exponent is going to be years. So to figure out this question, it says if I have $500 in my account after 4 years, right, that means I am ending with $500 in my account. Now, the question is asking us how much money did I start with? Well, that's asking me what my initial value is, so I can leave A as a variable. I can simplify 1 plus what is my rate, 0.025, right? Because we take every percentage and move the decimal over 2 places. And the exponent is going to be 4 because the money is in the account for 4 years. So now the question is, how do I find out what that A value is? Well, remember that this is multiplication. And although it doesn't look very nice, this right here is just a value, right? I can plug that into my calculator and get a value for it. So if I wanted to solve for A, what I can do here is I can divide by this entire value on both sides. 1 plus 1. That will cancel it out here, leaving my initial value alone, and then give me a value on the other side of $452.98, or approximately $453. So basically, I would have given the bank $453, and 4 years later, I would expect to have $500 in that account. Doing nothing, right? I'm just leaving my money there. That's how interest works. You're basically giving them your money, and they give you some money in return. So, let's look at another word problem. You deposit $100 in a savings account that earns 6% annual interest, compounded monthly. How is this question different than the one we just did above? Well, one main difference, obviously, is that they give us the initial value. So we're not solving for that in this case. But more specifically, what I really want to pay attention to is the wording. Okay? In the first question, it says compounding annually, meaning it is applying interest every year. In this question down here, we are compounded monthly. Well, first off, we have to figure out what that means. Well, 6% annual interest is still the same concept. So over the entire year, I'm still going to be making 6%. However, when they apply this 6% is going to be at different time periods than in the first question. Okay? They are giving me money monthly. So what does that mean? Well, in a 1-year period, they are going to apply interest 12 times at the end of every month. Okay, so comparing it to the first situation, if I had invested money in January in the first situation, I would expect them to give me the interest the following January, one time. But in this case, if I invest money in January, I can expect that they're going to apply interest in February, and in March, and in April, and in May, and in June, and in every month until the following January. So this is going to increase the number of times they are giving me money. Okay? But that 6% is not applied every month. Okay? That 6% needs to kind of be divided up for each month. So that's going to lead us to a new equation, okay? This is the compound interest formula that we're going to use when we see the words compounded blank, compounded monthly, compounded yearly. We can use this formula. So how does it work? Well, the end value, A, right, is the amount in my account after all is said and done. What is my final value? This p-value is called our principal. So when we're working with investments, we talk about principal. That's the amount you initially invest. So it's the same thing as our initial value. Okay? But they call it a principal because of the very specific situation. Next to that, we have a parentheses. That's still going to be our growth factor, but it's going to be structured a little bit differently. So we still have the 1 plus because we are growing, but that rate now is going to be divided by the number of times the interest is compounded. So for example, in the last question, if it's compounded monthly, I'm going to take that 0.6% and divide it by 12 because there are 12 months in a year. Okay? But just as I'm dividing that rate by 12, I'm also going to put a 12 into my exponent because I'm going to be applying this more frequently. 12 times as many years as there are because we'll do it 12 times in a single year. Okay? So let's do that. Let's talk about what these end values can be. So yearly and annually, we've already seen, right? How many times does this happen in a year? Once. Yearly happens once every year. Annually happens once every year. But as we move towards these other words, semi-annually, right? Semi-annually basically means twice a year. Okay, so we should expect to be compounding interest 2 times in a year. Quarterly, 4 times a year, right? Because we're breaking the year up into 4 quarters. Monthly happens 12 times in a year. Weekly happens 52 times in a year, and daily happens 365 times in a year, in most years at least. Okay, so when we look at this formula, right, the compound interest formula, we're going to be substituting those values in for the end value in my equation. All right, so going back to that question, you deposit $100 in a savings account that earns 6% annual interest compounded monthly. How much do you have in your account after 4 years? Well, the compounded monthly is the key that we are using this equation. Now we just have to fill in my values. Well, I want to know what my final value is. My principal is the initial amount, which is $100 I'm investing. 1 plus my rate as a decimal over monthly would be n is equal to 12. All raised to the 12 times, and how many years am I looking for? 4. Now you can plug this entire value into your calculator. I would recommend using a fraction key for this right there. But when you do plug that into your calculator all together, you get A is equal to 127.05. So now my last question for you is, why would somebody do this? Why do you want it compounded monthly? Why not just yearly? It is an annual interest rate after all. Well, let's take a look. Imagine this did not say compounded monthly, right? Let's say it was compounded annually. Okay, same situation, compounded annually. Well, technically, I can still use the same equation, but this time my n is equal to 1. So let's plug in the same values. My principal is still 100. 1 plus 0.06 over 1, right? Which is starting, if you know, when you have a decimal denominator of 1, you don't really need it. So it looks very similar to the do now question. My n is 1 and my time is 4. Okay, so if I actually simplify this, right, it ends up being exactly the same as the do now type of equation. Now, when I plug this into my calculator, I get 126.25. So the same amount of money, the same interest rate, will get more money over time when you compound it monthly. And that's because every time you compound your interest, you're taking the newest value you have in your account. So that means we're increasing the amount that's applying the interest rate every month as opposed to just once. So when investing, you want the most number of compounding periods as possible, because that will give you the most money for the exact same amount.